Okay, today we're going to be doing Module 1, Lesson 3, where we work on exponents and how exponents relate to multiplying and dividing on our place value charts. So, first of all, if you are unaware, an exponent is the number of copies that you have of a number. So you've probably seen them before. For example, if you have 10 with a tiny little 2 on the top, this right here is, that's a horrible arrow, this right here is the exponent. It's that small little 2. And what it's telling you is that you have 2 copies of 10. 10 to the second power means you have 2 copies of 10. 10 to the fourth power means you have 4 copies of 10. So you're going to have 10 times 10 times 10 times 10. So your exponent tells you how many copies you have of that number. We're just going to work within tens because that's what we're doing with our place value chart. But know that exponents work for all numbers. If you had like a 2 to the third power, you would have 3 copies of 2. So it would be 2 times 2 times 2. So exponents can work on all sorts of numbers. Now, when it says, question number 1, write the following in exponential form. Let's brainstorm some exponential forms before we even get started here. So I just went over how exponents are when you have something like 10 to the first power, or 10 to the second power, 10 to the third power, 10 to the fourth power, etc., etc., right? It would go on forever. It's just telling you how many copies you have of that 10. So 10 to the first power means you have 1 copy of 10. Let's do a different color, actually. So you have 1 copy of 10. 10 to the second power means you have 2 copies of 10. 10 to the third power is going to be 3 copies. And it's going to go on. If you have a 10 to the fourth power, you have 4 tens. However many exponents you have. You could have 10 to the millionth power, and you'd have 1,000,000 tens. Now, we know that these numbers, these exponents, and these equations can be thought of as regular numbers. Like, what is 10 times 10? Yesterday, or in lesson 2, we looked at how 10 times 10 is really the same thing as saying it's 100. When we broke down 100, we knew it was a 10 times 10. So we can think of these in standard form. So 10 times 10 is 100. 10 times 10 times 10 is 1,000. This first one's still just 10. 10 times 10 times 10 times 10 is 10,000. And I want to give you a secret. I'm not actually doing that math. I'm not doing 10 times 10 times 10 times 10. What I know and what I can tell by looking at this is I can see a pattern forming. I can see when I look at 10 to the third power, 10 to the third power is 10 times 10 times 10. It's 3 copies of 10. Well, I have 3 tens here. Look at how many zeros I have in 1,000. 1, 2, 3. So the number of copies of 10 is the same number of zeros. We actually looked at this when we were looking at place value charts, and we were looking at how many times you jump. It's the number of zeros in your number. So 10 to the fourth power, which is 4 tens, is 1, 2, 3, 4 zeros. So you can look at the exponent, and the exponent will tell you how many zeros you should have, and you can go backwards. You can look at how many zeros you have and can think what your exponent is. And that's what they're asking you to do here. When they say write in exponential form, they mean, okay, how can I write 1,000 as an exponent? Well, if I look at 1,000, I can see 1, 2, 3 zeros. So 1,000 is going to be 10 to the third power because there are 3 zeros, and 3 zeros means it's 3 copies of 10, which means 3 as my exponent. So it's all connected together. So you're counting the zeros here. Even if you see something like D, where it's 100 times 10, you're still going to count the zeros. So you're going to do 1, 2, 3. There are 3 zeros. 100 times 10 is still 10 to the third power. You could even do 1,000,000. 1,000,000, which is not on our chart, has 1, 2, 3, 4, 5, 6 zeros. So it should be 10 to the 6th power. It's all about pattern bases here. Now you can go backwards too, the other way. And now they're asking us to write the following in standard form. So they're giving us exponential, and we need to think about it backwards. And how can we go from exponential to standard? So if we look at A, 4 times 10 to the 3rd power. 10 to the 3rd power means 3 zeros. So I'm going to write it, and I'm going to write it down here so I can be a little bigger. I'm going to write 3 zeros. So 10 to the 3rd is really 1,000 because there's 1, 2, 3 zeros. So what this question is asking me is what is 4 times 1,000? If you can do that in your head, awesome. If you need to draw a place value chart and think about 4 times by 1,000 and how you're going to move 3 spaces, you can do that. But you end up with, one more space. 4 times 1,000 is going to be 4,000. So you're looking at writing it in standard form. That's step number 1, then doing the multiplication or division. So like C, 5,300 divided by 10 to the 2nd power. So my first step needs to be to translate that exponential form to standard form. 10 to the 2nd power, 2nd power meaning 2 zeros because it's 10 times 10. So it's 100. 10 to the 2nd power is 100. So my equation is really 5,300 divided by 100. And you can use your place value chart to solve that. It works the same for decimals. So if we look at F, 60.72 times 10 to the 4th. First step, 10 to the 4th is really, with 4 zeros, okay, it's 10,000. So my equation is 60.72 times 10,000. And again, I can do my place value chart and I can get that answer. Go ahead and pause the video and do that right now to make sure that you are practicing your place value chart work. Okay, let's do one last word problem. So it says, solve 247 divided by 10 to the 2nd power and 247 times 10 to the 2nd power. What is different about the two answers? Use words, numbers, or pictures to explain how the digits shift. So just looking at these, I can tell what's going to be different. In this first equation, 247 divided by 10 to the 2nd power, we're looking at division, which means our answer is going to be smaller. And in our second equation, 247 times 10 to the 2nd power, we're looking at multiplication. So our answer is going to be bigger. But let's solve it and we can prove it. 10 to the 2nd power is really 100. So I'm doing 247 divided by 100. I can draw a quick place value chart for that. 247. I'm dividing by 100, so I'm going to move it 2 places to the right. So I get 2.47. So my digits shifted 2 places to the right. When you're timesing instead by 100, our digits are going to shift the opposite direction. So they're going to shift 2 places to the left. So when they're asking us this, and we should draw this out too, 247 timesing by 100 means they're going to go to the right. Oops. 2 places. So we get 24,700. So you can see how much bigger multiplying is than dividing, and it's because the digits shifted 2 places to the left versus 2 places to the right. So using exponents just helps make the notation simpler, and it's telling us how many copies we have of our tens.